All right, hello everyone. My name's Tom Gemmell. I'm a part-time PhD student at Laurentian University with Metal Earth under the supervision of Harold Gibson, Bruno LaFrance, with lots of help from Rasmus Haugaard. And I'm also a Precambrian geoscientist with the Ontario Geological Survey. So I gave an update a few years ago, so basically this is just going to be a further update to what's going on in regards to the volcanic evolution and differential base metal endowment of the Swayze area within the Abitibi. So, and just a quick shout out, so basically because I'm with the OGS and with the field program that's going on since 2015, so Ontario has been sponsoring this as well as the Metal Earth program and Laurentian University. So just a quick outline. So I'll just talk about the research problem quickly, the state of current research. I'll go over the volcanic evolution and architecture of the area. So basically kind of summing up what will be in the manuscript number 1. The metal endowment, so characterizing base metal prospects. I won't be really talking about gold at all, but just looking at the base metal prospects because gold's already really been done. And then the implications that this might have to the Abitibi. So, research problem. Given that the Swayze area is the western extent of the well-endowed Abitibi greenstone belt and contains the same chronostratigraphic episodes, why does the Swayze area have less base metal endowment than the central Abitibi? So, and this just kind of sums this up. So this was as of 2017, and I know this number's upwards of this now, but basically we've had more than 775 million tons, over 800 million tons now of VMS base metal production within the Abitibi, and Swayze production to date is 0. So, and I just want everyone to keep an eye on these volcanic episodes, the time frame of what they represent, and this is going to be a reoccurring theme throughout this talk. So, state of current research. So, everyone knows this, but so just to show you my end of the world in the Swayze, so the southwestern Abitibi. So, the Swayze area, much like we just heard, it's very similar to the Michipicoten. So, we have ultramafic to felsic metavolcanic rocks. We have ultramafic to felsic intrusives, as well as metasediments, much like the rest of the Abitibi. So now looking at this is the current state of the mapping within the belt. So it started in 2015 in the southeast. This is where the Cote Gold and Gosselin deposits are. So basically all these outlines are representing maps and or preliminary maps, summary fieldworks that have been produced. You can see the seismic and magnetotelluric transect across the belt. And then the northeast has also been worked on by Peter McDonald and Leanna Weiss. So basically the plan with the OGS is just to continue westward and then upwards, and then we'll see where we get. I imagine by the end we'll just finish off the entire area. Then geochemistry and geochronology. So geological mapping, we have just been doing this across the belt. To date we have just over 1,800 samples produced and submitted to date, with around 150 more each year depending on how many townships we go after with the OGS mapping. And we have over 30 new uranium, lead, zircon ages. So that's the state of things right now. So now I'm going to review the volcanic evolution and architecture of the area. So this is just outlining the transect again where it was. This was mapped in 2017. And then just showing kind of the distribution of base metal and gold deposits. I won't talk about gold, but you can kind of see they are scattered across the belt, but we're mainly going to be talking about these right here and this area down here. And then these random circles, they're not deposits, they're just massive pyrrhotite pyrite occurrences, but I will go over those. So this is the episode distribution within the Abitibi greenstone belt, as well as the base metal distribution. So I'm not going to go into a lot of detail with this, but basically what I want to highlight is that within each of these episodes, these major episodes, volcanic episodes within the Abitibi, we have base metal mineralization. So typically they're within the episodes, they're not usually at the boundaries, and then with the Picard, I have this as a different color just to represent, at least in the Swayze area, that within the Chester intrusive complex, where the Cote gold and Gosselin zones are, there is some chalcopyrite, but that's the reason for that coloring, so there is a little bit of base metal there. But we're mainly going to be looking at the rest of these episodes, so they all have base metal endowment somewhere in the belt. So and just to review quickly kind of where this came from, back in the 90s, the GSE, Kevin Heather, and many others were involved with mapping the Swayze greenstone belt, as it was known at the time, 1 to 50,000 scale. So everything we've been doing since has been 1 to 20 or more detailed where required. And I just want to highlight that at this point we were kind of coming from lithotectonic assemblages, but we're still loosely controlled by time. So really they were starting to get to informal episodes at that point. But we were segueing away from the 55 lithotectonic, I think it was 55 lithotectonic assemblages that were in the Swayze or in the Abitibi, and then we started to actually look at this more autochtonously as time went on and we got more information. So this is where it stood when I started the project, as represented by this figure over here. We had a lot of Tisdale, Kiminrow to the north, Picard to the south, and a lot of Deloro kind of in the middle area here. And on the right you can see where we are now. So we have quite a bit of Blake River, which is a change from the Tisdale. This was largely because of inheritance issues, which I'll talk about a bit later, but it's actually a very significant part of our current interpretation of what's going on. So basically these are still kind of representing what the assemblages were, but we have a much more better time constraint with an emphasis on time. So that's why we're calling these episodes. So notice that all the significant base metal mineralization within the Swayze area, independent of the copper within the Chester intrusive complex, is located within this horizon right here. So I'll talk about that in a second. But basically, this is the Woman River Iron Formation. It was originally describing just this horizon, but through Kevin Heather's work and others, it basically represents the time gap between Deloro and something younger, where we have control. This iron formation is in contact with the Blake River, and then we have this unknown area which we are currently trying to lock down, but it looks like it's probably also going to be Blake River, but we are working on that. So and then also just to point out that this strat column on the left, or episode section, it does represent the distribution, the superficial distribution of these episodes within the Swayze area. So it's actually calculated from this diagram, so this is actually how much Blake River we currently have. It is ignoring the unknown area. And also to point out that we do have ultramafic volcanic rocks within the Blake River, as well as what's currently interpreted in the Kiminrow in the north, but there's work going on that right now. So this is just highlighting the Woman River Iron Formation as it stands currently. So the next thing I want to briefly touch on is inheritance. So in the Swayze area, and this is largely the reason why this distribution has changed so much, we have quite a bit of inheritance over quite a few episodes. So within the Deloro, we have inheritance of pre-Picard and Picard. Within Kiminrow, we have inheritance of Picard. Within the Blake River, we have pre-Picard, Picard, Deloro, Kiminrow, Tisdale inheritance within that episode, and then we do have inheritance within what we're calling the Chris for now, but basically just a volcanic equal time frame as the Porcupine in the Swayze area. So the important thing to point out is the central part of the Abitibi really doesn't have nearly as much inheritance, if at all. So this is a significant difference that we see within the Swayze area. So and this is just drawing a direct kind of comparison. I'll show in a second what I've used for the superficial distribution of the central Abitibi. But But basically, the only base metals we have in the Swayze area are associated with the Woman River Iron Formation, with an honorable mention to the Chester Intrusive Complex area. Yet in the Abitibi, like I've already mentioned, has VMS deposits in all of these episodes, and the time that these represent, we have a lot of these things in the Swayze, so that's going to be, again, a common theme going on. So this is just defining the areas that I use for the calculation of the rough distributions of the episodes within the western and central Abitibi. So this is kind of defined, and I'll talk about a bit later about kind of what David Mole has outlined in some of his recent works. So it is important to mention as well that there is massive sulfide, massive pyrrhotite pyrite within the Blake River. I'll talk about that later, but this is the only place currently recognized in the Swayze area where we do have massive sulfide, not endowed, but massive sulfide within the Swayze area. So this is just showing the composite section. So the main take-homes here is we do have all of these volcanic episodes. They are extensive, but they are thin. So if you compare this against the Noranda transect, it does not go, the supercrustal rocks do not go down as far. We do not see a well-developed central volcanic complex anywhere along the transect. The only synvolcanic intrusion we have is the Chester Intrusive Complex in the Swayze area that we currently know of. And then we do have these conductivity zones, but they're not as strong as other places, and they're associated with the transcrustal structures. So this is one of the main differences with the rest of the Abitibi. So just to sum all this up, we currently have an absence of Tisdale episode volcanic rocks, but this is currently under review. We have an abundance of Picard, Deloro, and Blake River episode volcanic rocks in the southern Swayze, with the latter two lacking volcanic centers containing subvolcanic intrusions. An absence of ultramafic rocks in all of the volcanic episodes except for the Blake River in the southern Swayze, and some within what's currently interpreted as the Kim Monroe in the north. We have anomalously thick, so up to 200 meters. They're definitely artificially thickened by structure, but they are extensive. They're up to 20 kilometers wide. They are thick. They're big, and they're the only things that contain any known base metal mineralization. And then we have significant inherited zircons compared to the volcanic rocks of the central and eastern Abitibi, and we do have sparse evidence of Mesoarchean rocks, or Mesoarchean zircons through LA ICPMS, but it's rare. So I'm always coming back to this diagram. So notice where most of this tonnage is, but just remember that what these things represent. This is time. So what I'm going to start leaning towards is more of a spatial control on where all of this tonnage is versus what we've been using, time. So we're going to look at these base metal prospects in a bit more in detail. So this is kind of the second part of my PhD, so just characterizing what these things actually are and what they look like. And of course, all of the base metal mineralization, again excluding in the Chester Intrusive Complex, is along the Woman River Iron Formation. So I had a master's student, Blake Mowbray, do an extensive amount of work on this extent of the Woman River. Not sure if he's going to complete his work, so but we'll see what happens with that. But regardless, I'm going to show some of his observations and some of his interpretations. So first, going to look at Jefferson and Vencan. So these two right here, I'm not really going to talk about Stockpool. So he has, this is, on the left is an idealized section through all three of these prospects, which is from drill core and from his trench mapping that he did. So he has, within the stratigraphic base of the deposit, he has, as you can see in this picture here, there's chlorite-rich alteration in the stratigraphic base of the deposit. We have stringers of chalcopyrite and sphalerite going into the base of the iron formation. and replacing the base of the iron formation. And then you can see on the left, the hydrothermal alteration goes up above the iron formation. So I'll talk about this right at the end and a little bit in the next slide, but this is something that this summer I'm going back out into the field to try and nail down exactly what's going on with this upper contact. So specifically the Jefferson has, this is non-compliant with NI 43-101, but it has an unofficial resource of 30,000 tons at 7% zinc, 4.6% lead. And this trench map is basically representing this upper section here. So we have these mudstones, argillites, they have abundant garnets in them. And then we had, Blake had an interpreted limit of alteration within here, so stratigraphic up would be towards the top left. So we do have a bit of infiltration of these units, but it's important to figure out if these are actually some volcanic intrusions or if they're truly lava flows. That's something I need to lock down this summer. This is the Vencan area, so this is kind of representing a lower section of the iron formation. And the main take home with this is the massive sulfides that we have here. So we have chalcopyrite and more so sphalerite, that the mineralization is cross-cutting the iron formation. So we do have cross-cutting relationships here. So in summation, at this part of the Woman River iron formation, this is basically what we have. We have our discordant alteration zone in the stratigraphic base. We have a replacement of the iron formation above, and then evidence of hydrothermal alteration into the overlying rocks, but we need to figure out exactly what's going on here because we're still not exactly sure. So now we're going to keep within the Woman River iron formation, but we're going to move over to the Shunsby area. So we've moved westward across the belt, and so we're going to look at the Shunsby prospects. So it's still within the exact same time gap, at least above the Deloro as we know. And we're basically going to look at the northern area here. Again, this is non-compliant, but it has an NI 43-101 resource of 2.6 million tons at 1.83% zinc and 0.47% copper. So this is the north prospects. We're going to be looking at Copper Knob and the main zone. So I'm just going to be talking about kind of early observations from these areas. So in Copper Knob, we've gone through and we mapped in detail all the fractures, contacts, faults, and mineralization areas. So we have chert breccias, we have massive sulfide, either clasts or fragments. We have thin sections of this, which I have yet to look at. But basically we're going to try and figure out if this is replacement of sedimentary clasts or if this is actual massive sulfide fragments that have been ripped up and made a part of the breccia. And we have some nicely bedded cherts, but just distally this, we also have some very decent grades within those areas. Within this outcrop as well, we have quite a bit of fracture control mineralization. So on either side, we have what are basically semi-massive sulfides. And within the two, we actually have complete replacement, and we have massive sulfide, basically pyrrhotite and chalcopyrite entirely. So over 50% massive sulfide between these fractures. And in the same outcrop, we also just had hydrothermal fluids using the fractures between some of the breccias. And this is, again, all chalcopyrite and pyrrhotite for the most part. So it's Copper Knob, so now just going to take a quick look at the main zone, just down the hill. So our main lithology is kind of a muddy chert, which has kind of background base metals. We also have a mudstone that's fairly heavily deformed, but where it's quite wide and developed, again, we have background values, but when we have this unit very thinly between chert beds or things that are much more competent, we have much higher grades of base metal. So as you can see here, there's a chert layer here, a chert layer here, and in between a mudstone. And both of these samples were over our detection limits just for our trace base metals. So this is indicating that in these tectonic breccias, the mineralization was likely initially there as strata-bound mineralization that was then remobilized during deformation. So I'm going to look at one more spot along the Woman River Iron Formation. This is not very much base metal endowed, but it's still massive pure-type pyrite. So this is the Mortimer Magnet Jasper prospect. And I'm just going to basically go through it, but we have an oxide facies banded iron formation. Within it we actually have a tough siltstone unit that's of Staunton Rockmire age. We have just a normal siltstone intermixed, a replaced sulfide banded iron formation, and then a breccia with sulfide in the matrix at the base. So I'll just quickly show the pictures. So that's the oxide BIF. This is the replaced banded iron formation. It's now almost entirely purite, and those are the grades with it, so it has a little bit of zinc. And then this is the breccia at the base, where these fluids would have been coming up and likely filling up below the iron formation. So and then just quickly, the unit within the Blake River, this is the only unit within the outline of a volcanic episode and not at its boundary. So we had a bachelor student in Byers at St. Mary's do some work on this. And basically it's an isolated occurrence. We don't have any contact relationships because it was an old showing. But it's just significant that we do have sulfide mineralization. We have massive sulfides, not of economic grade, but within the Blake River. So the early characterization of these is all of the base metal mineralization, excluding at Cote, Gold, and Gosselin, in the Swayze areas within the Woman River Iron Formation. The hydrothermal mineralization and or alteration occur stratigraphically below and within the iron formation, and we're still trying to resolve what's going on above to figure out the exact timing. And then the only occurrence of massive sulfide mineralization recognized that doesn't occur within the Woman River Formation is in the Blake River. So now, I'm almost at the end, but quickly some Abitibi scale comparison. So what are the implications of everything I've just said? I haven't really alluded to what's the importance of this. I've just kind of stated what's there. So as we've seen, VMS deposits occur in each of the volcanic episodes across the Abitibi. However, I want you to look at, as we've all kind of seen in the past, where they're generally located. So if we look at the Abitibi's endowment based on specifically time, all three of the most important episodes for VMS base metal mineralization are present in the Swayze area, with special emphasis on the Blake River as it contains the most tonnage, and that's our biggest episode. So, and it's the most voluminous in the Swayze area. So the only base metals in the Swayze are either in Picard episodes in volcanic intrusion or in the Woman River Iron Formation at episode boundaries. So if we look at David Moll's work and others, for the entire synvolcanic time slice through the Abitibi, the Swayze area is a much more chondritic, older epsilon hafnium expression, which is what Sarah was kind of alluding to earlier as well. So this fits very well with what David Moll's done and Sarah. So we don't have depleted mantle juvenile-like values like the central part of the Abitibi, as you can see here, which is where all the volcanic episodes are that are VMS endowed. And according to David, represents an area of the Abitibi that underwent sustained, continuous rifting, extension, and volcanism throughout construction of the Abitibi, which are all favorable for VMS production. So this is just kind of outlining that same central area that I showed earlier, so this is kind of what I'm referring to as the central Abitibi. So the implications, kind of all put together. So the Western Abitibi, the Swayze area, contains VMS endowed episodes. However, underlain by thicker crust, less juvenile crust, we had less volcanism, less extension, less plume activity until near the very end. We have abundant inherited zircons within volcanic rocks, so this is kind of more indicating that we're towards a rift margin. The only synvolcanic intrusion is very old within the area, so it's the Chester volcanic complex. Long inter-volcanic periods of sedimentations. The Woman River Iron Formation is very thick, and it's the host to our only VMS-like mineralization. We have an extensive but thin Blake River. There's no known central volcanic complex like the Flavian and the Noranda area. Schematics indicate that there's late rifting, but it may have been too little too late, and the only known inter-episode massive pyrite pyrite mineralization occurs there. Time as represented by volcanic episodes is not entirely indicative of VMS prospectivity. So the summation statement is VMS endowment in the Abitibi is localized to central area that is characterized by sustained long-lived volcanism, magmatism extension, rifting throughout the construction of the belt. And more simply put, the Swayze area was the right time but the wrong place for VMS base metals. Thank you.